So let's move to chapter 1. Chapter 1 is very elementary and it is for self-study. So you will study at your own, but I will take up some key points to start with. So let's start with the definition of differential equation. I will use this abbreviation further also for differential equation DE. So what is a differential equation? An equation carrying a dependent variable and its derivatives. An equation carrying dependent variable and its derivatives is called a differential equation. Differential equations naturally arise in various situations. So let me describe one situation where you will see a differential equation immediately. Suppose we are filling air into a spherical balloon. Air into a spherical balloon. Means while filling the air, it is taking the spherical shape. And I'm interested to know its surface area at any given value of R. Rate of change of surface area at any given value of R, say R0 or R1. So what is the differential equation from which I can calculate it? Or what is the differential equation governing this situation? So it is very simple to calculate. You know surface area is connected with the radius via this relation s equal to 4 pi r square. So ds over dr is equal to 8 pi. So this differential equation covers that physical process filling air into a balloon. So at any given value of r, you can calculate the rate of change of the surface area. So likewise, there are numerous situations where you get natural differential equations, and the purpose of this course is to learn analytical methods for solving different types of differential equations. Okay. So let us move to the next definition. By the way, in the differential equation, what is dependent variable and independent variable? R is independent variable and S is dependent variable. Okay. Next thing, order and degree. One more point, you need not to write various things right now. You can follow the online lecture notes for this course, which are available on my website. Okay. Here, just you focus on understanding different things. Okay. Catch the concepts very well. That will be helpful. So no need to write. If I give something here to solve, just solve that. All right. So what is the order of a differential equation? Order of the highest order derivative occurring in the differential equation. For example, this is a differential equation. And what is the order here? It's 2, because the highest order derivative that is appearing in this differential equation is 2. So order is 2. And what is degree? Exponent or power of the highest order derivative occurring in the differential equation. That you can see is 1, so degree is 1. So it's a simple concept you understand. You can characterize differential equations by their order and degree. All right. After that, what's an ordinary differential equation? Ordinary differential equation. An equation carrying only one independent variable. You can say here x is the only independent variable. So it is ordinary differential equation. And what is partial differential equation? A differential equation carrying more than one independent variable. For example, or in simple words, we can say differential equation carrying partial derivatives. It's called partial differential equation. This is a famous differential equation known as Laplace equation. It has physical applications. You will learn later. For the time being, just understand this. This is a.
Excuse me, sir, the board isn't clear.
Sorry?
The board isn't clear.
Board is not clear?
Is the resolution?
I don't know,
It's
but
clear. Sir, it's
here
clear.
it's very clear. I'm seeing on my desktop. So maybe because of the
Sir, stream at 720p, sir.
Sorry?
Stream at 720p, sir.
Yeah, it depends on the internet connectivity on your side. Okay, so don't worry about it. I will forward this video lecture to you. Okay, you can watch it later, but at least it should be visible what is written there.
Sir, it is visible.
Yeah, that's what I'm saying. Maybe to some students it's not clear.
Sir, just check on the bottom right corner, sir, at what resolution you are streaming, sir.
Bottom right, what are you telling? Can you repeat again?
Sir, just check at the bottom right corner. There is an icon, sir. Just click on it and check the video quality at which you are streaming, sir.
Okay, but this kind of thing is not here. I'm saying it.
So you'll have to go to settings and then video.
Yes, sir. Video settings.
Okay.
So in the three dots menu.
Yeah, in three dots menu, I'm seeing here change layout, full screen, turn on captions.
Settings, sir.
Settings, okay. In settings, what should I do?
Sir, go to the video part.
Video.
Right, then
Send resolution maximum.
send resolution. Okay, let me make it 720. Right now
Yes, sir.
it is
Yes, sir.
360. Okay. And receive resolution, that is not needed to change.
No, sir.
No,
That is
sir.
not needed, right? Okay, so I'm doing it. I've done it. See it now.
Yes, sir, it's okay
Yes, sir.
now.
So it improved a lot.
All right. Okay. Okay. So I was telling that depending on the number of independent variables present in the differential equation, we have two categories: ordinary differential equation and partial differential equation. Ordinary carries only one independent variable. Partial carries more than one. For example, here u is dependent variable that depends on x as well as y. Okay. Now, a very important definition: linear differential equation. That you should listen carefully. A differential equation in which dependent variable and its derivative, dependent variables and its derivative. By the way, after this, we will be dealing with ordinary differential equations. So, okay, if I'm telling differential equation, that means ordinary. Partial differential equations you will see in one chapter, but after mid semester. Okay. Mainly, we will be dealing with ordinary differential equation. All right. So, what's a linear differential equation? A differential equation in which the dependent variable and its derivatives occur in the first degree and are not multiplied together. For example, is it linear? You can type your answer. Is it a linear differential equation? Xy double prime plus 3y prime plus 2y equal to 0. Yes. And what about this equation? Second changed equation, I made it y square. It is not linear because the dependent variable y occurs in more than 1 degree. It is square. Alright. Likewise, I can write something like this: y double prime plus y prime plus 3y equal to 0. This equation is also not linear because the dependent variable and its derivatives are multiplied together. So the thing is that, can we write the most general form of the linear differential equation? Yes. Most general form of the nth order linear differential equation can be written in the form a0xyn plus a1xy minus 1 plus and so on a minus 1 x y prime plus a y x and xy equal to some function x. That is the most general form of nth order linear differential equation. Right hand side could also be a function of x. If right hand side function Rx is 0, you call it
Sir,
homogeneous.
that part is going beyond the camera. We can't see that part of the board.
Okay. Plus a y a x y equal to Rx. Is it now visible?
Yes, sir.
Okay. So if Rx is 0, we say it's homogeneous, otherwise non-homogeneous. So this is the most general form of linear differential equation. Any differential equation which is not linear, of course, that is non-linear. So we will learn later how to solve linear differential equations. Just I'm telling the classifications of different types of differential equations. Now, what do we understand by solution of a differential equation? This is very important. What kind of solutions exist for a differential equation? Let's first consider the most general form of a nth order differential equation. I'm not saying linear or non-linear, nothing. I've written function of x, y, y prime to yn equal to 0. Any function connecting these variables x, y, y prime, y power n is equal to 0. That represents nth order differential equation. Now, what do we understand by its solution?
So,
Yes.
so what is the last term in the LHS? Should there be a y there? The last term of the LHS, should there be a y there? I think, shouldn't it be a and x? That's it.
No, why should be there?
And the second last term is a n minus 1x y raised to 1.
Yeah,
And the
y
last
prime,
term is
that
also y raised to 1.
is y prime, that is derivative, not y power.
Oh, right. Okay. Thank you.
Okay, how do you denote derivatives? How do you denote the fourth derivative of y with respect to x? 4, 5, and so on. We write like this, and last one. 1. You should know these standard notations about derivatives. Okay. All right. So I'm discussing now different types of solutions of a differential equation. It's very important part, as I said earlier. So let's see one by one. First is implicit solution. What do we mean by implicit solution? Y equal to Gx is, sorry, what's explicit? Explicit solution. Y equal to Gx is explicit solution of this differential equation if fx, z comma z prime and so on, gn. This thing is identical to 0. In simple words, you can say that y equal to Gx satisfies the differential equation. Then it is explicit solution of the differential equation. Okay. Why I calling it explicit? Because y is explicitly given in terms of x. So this is explicit solution. Next is implicit solution. Hxy equal to 0 is said to be implicit solution of this differential equation if it produces at least one explicit solution. If it produces at least one explicit solution. I will give example to that part also, but let's see one example for this explicit solution. Y equal to e power minus x. Just check whether it satisfies this equation. Yes, it satisfies. If you substitute y equal to e power minus x into left hand side, you get 0. So it is explicit solution because y is explicitly given in terms of x. Now I am telling the next thing. Implicit solution. A relation of the form hxy equal to 0 is said
Sir,
to
so can you say that all explicit solutions are implicit solutions?
all explicit solutions are.
Implicit solutions. Because they can all be represented as hx,
The idea behind explicit and implicit, let me complete it, then you will understand. Okay. So if this relation gives at least one explicit solution, then it is implicit solution. Let's see an example. Through example, you will understand immediately what I am trying to tell. Consider this differential equation y prime plus x equal to 0. Now look at this relation. I say that it is an implicit solution of this differential equation because from this I can write two explicit solutions. I can write two explicit solutions. You can verify if I substitute y equal to plus square root of 1 minus x square here, this equation is satisfied. Likewise, you can put minus. Okay, because this relation is producing two explicit solutions or one explicit solution, so it is, this relation is an implicit solution. But look at this one. This is also a solution. This is also a solution because if I differentiate both sides with respect to x, I can get x plus y prime equal to 0, which is the given differential equation. But it is not an implicit solution. Why? Because you cannot get any real y from it. Whatever value of x, y you choose, this cannot be minus 1 because it is the sum of squares. So, these solutions are not of interest, but we call them common solution. Common solution. A solution of the differential equation that doesn't give an explicit solution but still a solution. It's a formal solution. Or for the general solution, listen carefully about general solution. It's very important. A solution that carries number of arbitrary constants equal to the order of the differential equation. Again, I repeat, a solution that carries number of arbitrary constants equal to the order of the differential equation. That solution is called general solution. For example, y prime y equal to 0 is the differential equation. Y equal to c times e power minus x. You can check it's a solution, and also it carries one arbitrary constant c, so it is a general solution. Why general? Because it is first order differential equation. Let's take another example. I'm taking second differential equation as y double prime plus y equal to 0. Then y equal to c1 cos x plus c2 sin x. You can check it satisfies the given differential equation. Also, it carries two arbitrary constants, c1 and c2. And order of this differential equation is also 2. So it is general solution. And after general solution,
Sir, is it necessary that explicit solution is a function of x?
not necessary, it could be constant also. For example, you can take y prime equal to 0. What is the solution? Y equal to a constant. Alright. So next thing is particular solution. Particular solution is obtained by giving particular values to the arbitrary constants. For example, I take the same differential equation and I write something like cos x plus sin x. You can see c1 and c2, I have taken 1. You can check it is a solution, but it's a particular solution. The solution obtained by giving particular values to the arbitrary constants in the general solution is called a particular solution. There is one more type of interesting solution. That is the final one. Singular solution. There may exist a solution of the differential equation which is a solution but cannot be obtained from the general solution by giving particular values to the arbitrary constants. See this example. First check this expression y equal to cx plus c square. Substitute y equal to this into this whole expression and see in this differential equation and see whether it is satisfied or not. You can check it will be satisfied. Okay. Now look at this one. Y equal to minus x square over 4. Substitute here. Again it is satisfied. But whatever value of c you choose, you cannot obtain the solution. Such a solution is called singular solution, which cannot be obtained from the general solution. Okay. So I have covered different types of solutions of a differential equation. You should know about these. Next is initial value problem. What is initial value problem? We'll understand through this example. Suppose this is the differential equation y double prime plus y equal to 0. I know its general solution is c1 cos x plus c2 sin x. Now to determine these constants, I need some conditions. Let's say I specify two conditions, y0 equal to 1 and y prime 0 equal to, say, something 5. Okay, using these conditions, I can determine C1 and C2. But see carefully, both conditions are specified at a single point, 0. Okay, so if the conditions are specified at a single point to determine the particular solution or to determine the arbitrary constants in the general solution, then we'll say that it's an initial value problem. But if the conditions are specified, say something like this, y0 equal to 1, y pi by 2 equal to 0. Now, this problem is a boundary value problem because the points are different now. Okay, so we have two types of problems: initial value problem and boundary value problem. The only difference is about the points where the conditions are specified. If the conditions are specified at a single point, then it's initial value problem. Different points, it's boundary value problem. So hope you understood all these things that I've explained today. Okay, now the thing is that how to approach to this course. First chapter is elementary. It is basically for self-study, but still I have taken some points from this chapter. So how to approach to this course? How to prepare well? This is a very important point and you should know from the day one how to approach to this course. As I said in the beginning, this course is about analytical methods for solving mainly ordinary differential equations. You will see some methods for solving partial differential equations also, but in most of the course we will be doing ordinary differential equations. Okay, this is the main purpose. So you will learn very elementary and classical methods for solving different types of differential equations. This is the purpose of this course, and alongside you will see some applications as well. Okay. So thing is that how to approach to this course. I'm coming to the same point. I'm explaining the key points in the lectures, the basics. Same points are given in the online lecture notes. So I suggest all of you to follow the lecture notes along with these lectures. First, clarify your basics. That is important. And do it on regular basis. Suppose you are not able to attend some particular lecture. It's fine. You have lecture notes. You can read them in advance also, so that you have a better understanding when you attend the lecture. Okay? This is one thing. Second thing is that after listening the lectures, there are exercises in the textbook and there are very good problems there. Please do the exercises. Once you are done with the lecture and you are seeing that, okay, up to this much it is covered and some exercises given there in the textbook, let me do it. Let me try some problems there. So do the exercise problems whenever some sufficient work is done in the lecture. That is second point. One more thing that is not within this course, but I will suggest you to do. That is very interesting also. I hope you will love to do that. You can write Python programs to solve the differential equations analytically. I have given some, I have already put some Python programs in my online lecture notes. Okay. In some lecture, I will demonstrate you that how to use them for solving the differential equations. Please follow those programs also. What is the advantage of doing that? Suppose you are doing some problems from the exercise and you are not sure what the answer is. You can use your program to know the answer in advance. And also you should know programming. It's the time of programming. Okay. So if you learn some methods, some Python programs for solving the differential equation, that would be very good. I will try to update the lecture notes as much as possible with the Python programs. Okay. And maybe in some programs I will need your help to develop it in a better way. But remember that this is not part of the course. It is an extra thing, and that depends on you. But I will suggest you to learn it. Okay. And the programs, writing the programs is very simple in Python. I will explain you. But even if you don't know in the beginning, you can start using the program just by copying and pasting the programs from the online notes. I will tell you, you need not to install Python on your system. Okay, you can directly use those programs on internet. There are websites where you can run the Python programs. Okay, but that is very important, and that would be interesting as well. All right. So before leaving, let me summarize what we have done today. So what I have told you mainly in this lecture, I have told you what's the differential equation, its definition, then order and degree, then classification, ordinary differential equation and partial differential equation. After that, types of solution. Then initial value problem and boundary value problem. You can recall that one by one. What's a differential equation? An equation involving a dependent variable and its derivatives. What is order? Order of the highest order derivative occurring in the differential equation is called its order. Degree, power of the highest order derivative occurring in the differential equation, provided it is free from radicals, etc. Because power should be integer. What is ordinary differential equation? Which carries only one independent variable. Partial differential equation carrying more than one independent variable. What are types of solutions? One by one, these that you should know. First, explicit solution. What is that? The solution of a type where y is given explicitly in terms of x. Implicit solution is solution that looks implicit but gives at least one explicit solution. Formal solution, there could be a solution which doesn't give any explicit solution. Then general solution, very important. What's the general solution of a differential equation? A solution that carries the number of arbitrary constants equal to the order of the differential equation. Particular solution is solution obtained by giving particular values to the arbitrary constants. I told you one more type of solution called singular solution. What's a singular solution? A solution that cannot be obtained from the general solution, but still it is a solution. So that is singular. After that, I've told you what initial value problem and boundary value problem. Initial value problem means if the conditions to determine arbitrary constants in the general solution are specified at a single point, it's initial value problem. If the conditions are specified at more than one point, it's boundary value problem. So these are very elementary things for the beginning of differential equations. Please read these from the online notes. All these things are written there with examples. So in the next lecture, we will begin with the first order differential equation. Methods for solving first order differential equation.